Hi, in the previous video, we looked at the solution to the problem that we defined without using the interrupt. And in this video, what I want to do is I want to show you the solution with the interrupt. And instead of using Tinkercad, I am going to be using the Arduino physically that I have here. Um, the only thing that I've done is I have put an LED here connected to pin 12 and the ground of the Arduino, and I'm going to be using this wire to give an input to the Arduino. Instead of the potentiometer, what I'm going to do is I'm going to connect this wire in turn to ground, 3.3 volts and 5 volts. Okay, so let's try out this program. And before I explain the program, what I'm going to do is I'm just going to run the program and show what it does, and then we'll look at the code that is here. Okay, so let me just upload this code onto the Arduino. Hopefully it compiles. Yes, it's uploading and it's done uploading. Okay, so if I put this on ground, you can see the LED is still off. If I put it on 3.3 volts, can you see that the LED is on? And if I put it on 5.5 volts, again the LED is on. Okay, if I go to ground, the LED is off. Okay, so if instead of this wire I had put a potentiometer and the voltage was above 2.5 volts, the LED would have gotten on, otherwise it would have been off. Okay, so let's look at what I've done in the program. Okay, our program starts with, uh, let's start by looking at the main program, okay? So the first thing I do is I initialize the IO ports, that's the input output ports, and I'm calling a function to do that, and the function is defined in these three lines here. And basically I'm defining pin B4 and B5 to be outputs. Okay, so these are 1 1 and the rest of the inputs in TTRB are 0, so they are still inputs. Next, what I do in the main program is initialize my ADC. So the initialization routine for the ADC is here, and there are no surprises here. Uh, Everything is very similar to the previous program. The only thing that I've done is I have enabled the ADC interrupt because that's what we are going to use. Uh, and whenever that interrupt is generated, so just to repeat, ADC interrupt is the interrupt that is generated when the ADC conversion is over, right? So I have enabled that. I have enabled the ADC here, and then I start a conversion. Okay, so right at the time of the initialization, after I finish all the initialization, I start the ADC conversion. Then I enable the system interrupts, and basically the program goes here and waits at this while loop for a till it gets interrupts. Now the interrupt service routine is defined here. So I'm writing ISR, and in brackets I have written ADC underscore vect. So that tells the the program that the interrupt service routine belongs to the ADC interrupt. Okay, and what am I doing in the ADC interrupt? Fairly straightforward. I'm just seeing whether the ADC value is greater than 512. If it is, I set pin B4 to 1. If it is not, I set pin B4 to 0 and I restart the ADC. Is that okay? Okay, so let's take a look at the program again. So I have already uploaded the program. The program is already there, and hopefully you're able to see this. So, well, let me check whether you're able to see it. I'll just have to pull up another screen. Okay, so what I do is at 0, you can see that this LED is off. Now I'm going to put it at 5 volts and the LED goes on. Okay. Uh, The LED was on a moment ago. Okay, right now it's on. Now if I take it out and put it to ground again, the LED gets off. If I put it at 3.3, the LED is on. Uh, my room is very bright, so you may not be able to see whether the LED is on or off. So let me pull the curtain. Hopefully that would help. So that's LED on. If I put it back to ground, the LED is off. If I put it to 3.3, the LED is on again. And if I put it to ground again, it's off. Okay, so that's the program that is running here, and this is using an interrupt.